In 7.5, we're going to be working on rationalizing denominators, which I know I showed you at least one time early. There's an L over here for radical expressions. Now, here's the thing, is I know you guys learned this in Algebra 2 or earlier, but in the years past, students have really struggled with this. It's understandable if you are not very good or you have questions, because I'm used to a lot of questions on this. And I think part of the issue is when we get down to this cube root. I think another reason why there's a lot of questions is because there's fast ways of doing this, there's slow ways. You just have to figure out what one way that works for you. So the easiest, and these are all division, but as I mentioned before, this program doesn't always have the divisions show up, is what you need to do is look at the index. That is very important, because what you have to identify is a perfect, this first one, let me explain the way you're typically used to, is you multiply top and bottom by the square root of 3, what the square root is in the denominator. Now you cannot multiply the whole number 5 with the radical 3, so just leave it as 5 root 3. And in the denominator, you have root 3 times root 3, which is the square root of 9. And we know the square root of 9 is 3. So our final answer is 5 root 3 over 3. So I didn't really explain, but radicals are not rational numbers. And at least for a while before calculators, calculators didn't really like, I guess maybe as math teachers, didn't like to have irrational numbers in the denominator, so we rationalized the denominator by making it a whole number like this. Now, as I move forward to the next problem, first of all, simplify where you can. For instance, I know the square root of 25 is 5, so it's like 3 times 5 over, I know the square root of 4 is 2, but we don't know the square root of x. So what we're looking at is 15, because 3 times 5 is 15, over 2 root x. Now how I would do this problem is multiply top and bottom by square root of x. And just like before, if you understand the shortcut, that root 3 times root 3 will give you exactly 3. Well, in this problem, root x times root x will just give you x. And in the bottom you have 2x, and in the numerator you cannot multiply 15 times a radical, because 15 is a whole number, the radical is not. Now, what am I talking about? That sometimes students don't want to do the problem my way. So I'm going to do this off to the side. Maybe if I went back to 3 root 25 over root 4x. And let's say you're a student that's really picky and you just want to do root 4x over here. So what you get, if you do this, maybe this student's way, is root 25 times root 40, root 25 times root 4 is root 100x all over root 4x times root 4x is 4x. But now you have a lot of simplifying to do, because I know the square root of 100 is 10, and I can bring that in front. Well, you have 30 root x over 4x. But now what you need to do is divide top and bottom by 2. 30 divided by 2 is 15. 4 divided by 2 is 2, and you get the same answer. So can you do this problem in a different way? Absolutely. It just might cause you to do a little bit more work then at the end. And then the other reason I believe I had a lot of questions on this unit is because what happens when you get to root an index of 3? Well, here's the thing. Let's do this wrong for a second, and then I'll erase. Is you can multiply top and bottom, okay, because this is a division, by cube root of 9. All right, there's nothing wrong with this, except it's not going to help us. Why? Well, if you did cube root of 9 times the cube root of 9, you get the cube root of 81. Well, if you try to break down 81 you get 3 cube roots of 3, you still have an irrational denominator. So that's not correct. So that's what I mean by why a lot of students mess up with this, or they get confused, is because they don't realize that there's a methodical way of doing this problem. So let me get you going on the right step. So this is the cube root of 2 over the cube root of 3 times 3. I just broke down 9 to be 3 times 3. So my question to you would be, well, how many more 3's do I need to have 3 of them? Well, I have 1, 2. I need a third 3. And why does that work? Is because we now have the cube root of 27, and in the numerator we have the cube root of 6. Well, we know the cube root of 27 is 3. And that is your final answer. So just because I showed you one example, you might still have a question. Write down that question and you can bring it to me. Bring it to class. I also want to point out that you can check your answers with a calculator. If you were to hit math, the fourth option down is the cube root, alpha y equals, will make a fraction of 2/9. Okay, so some decimal. What I'm saying is that's equal to what I came up with, which was the cube root of 6 over 3. It's the same exact decimal. So you can check your work still as we move forward. And don't forget, there's other ways of doing these problems as well. I feel like I've over-explained, though, at this point. So in this one, we're back to the square root. So I'm going to multiply top and bottom by root 5y. So as you do that, the numerator is just square root of 15yz. And then the bottom, root 5y times root 5y is just 5y. So the more practice you get, the easier it becomes. Now this is my opinion, so you might disagree with me. But as I'm looking back at the cube root again, and if I were to break down 27, we actually just did this problem. It's 3 times 3 times 3. So what I'm looking at is I have the cube root of z squared. I'm not worried about the numerator. I'm only concerned about the denominator. Over 3, how many x's do I have? I have 4 x's. Well, I can bring 2 of them, one set of 3 in front, but then I have 1 more remaining. And this one that has to be left over. Well, I need 2 more to get to 3 of these. So what I need to multiply top and bottom by is 2 more x's to get rid of this radical in the denominator. And I hope you agree there's 1 x there, and then there's 2 x's there, that I can match this pair with this pair, so then I get in the denominator 3x squared. See how there's 2 groups of 3? I really shouldn't call them pairs. And in the numerator, I have the cube root of x squared z squared. X squared z squared. And this is your final answer. It's going to take practice. If you understand this already, then you probably don't even need to be in this class, which might be true. A few more tricky problems, and I think I might save the rest of this for a second video. All right, maybe I'll do 2 of these and then finish up with the second video. Yeah, that'll be about good. There's a phrase in when we get to complex numbers that are called conjugates. You don't need to know this word, but I'm just bringing it to your attention. And it's not really a conjugate, because we talk about conjugates for complex numbers, and these are not complex numbers. But basically what it boils down to is we can't just multiply top and bottom by the radical. We need to somehow get rid of all radicals. So what we're going to do is rewrite the denominator, except we changed the sign from a plus to a minus. And if we multiply the bottom by that, we need to multiply the top by the same thing. So let's work with the denominator first, okay? Because the numerator is pretty easy once we look at that. So if we multiply and we FOIL this out, 3 root 2 times 3 root 2, 3 times 3 is 9, root 2 times root 2 is 2, it's the square root of 4, which is 2. So 9 times 2 gives me 18. Now, the reason why you have to change the sign is because the outside term is negative 12 root 2, and the inside term is positive 12 root 2. So those radicals cancel out as well. And maybe I'll show that work. Minus 12 root 2 plus 12 root 2. So those two pieces cancel. And then the last term, 4 times negative 4, is negative 16. Notice that all of the radicals go away, and in the numerator, in the denominator, you just get 2. Now also notice I'm not going to actually distribute this 2 in here, because what I can do, and what I would prefer to see out of you guys, is to cancel out these 2's, something we talked about earlier in the year. If you forgot, feel free to ask questions. So this answer is actually just 3 root 2 minus 4 when you simplify it all together. So I'm just going to put a giant capital N here because I'm talking about the numerator. I didn't actually do anything for the numerator. And hopefully all of that makes sense. Yeah, I think I have enough time to do one more, and then I'll share a second video with you. So stick with me. I'm just looking at the denominator, rewriting everything, and changing the sign. So if you do that to the bottom, you have to do that to the top. So let's just look at the denominator real quick. Root 5 times root 5 will give me 5. The outside term would be positive root 15. The inside is negative root 15. And positive times negative is negative. Root 3 times root 3 is 3. So all of these radicals cancel out. Now this time you do need to, or you should, I guess, FOIL the numerator. Root 30. Now I'm going to do some math in my head. Root 6 times root 3 would be root 18, which you can break down as 3 root 2. Now the inside term is 2 root 5, and then the last term is 2 root 3. And there's really nothing else to do except you can combine the like terms in the bottom, 5 minus 3. So the best answer there is everything I did in the numerator. And again, feel free to write down questions or question me. Maybe I did something wrong. And we can talk about it in class. All right. Like I said, I'm going to stop the video here, and I'm going to pick it up with this last example, and then we have exercise 5, 6, 7, and then you should be ready for the homework. So I'll see you in the next video.